Re-
All right, so this is my first video that I'm giving a go with geometry. It's section 4.1, and we're talking about transformations and on a coordinate plane. And it's kind of a review of Unit 1, but we're blending it with a little bit of coordinate plane information and algebraic descriptions of transformations. So we'll just get right to it. All right, so this is a translation of a polygon, quadrilateral specifically, and this quadrilateral is named HDKN. And if you recall from Unit 1, the primes, like up here, indicate that this is the post move, also known as the image, and the before move is called the pre-image, is what they call it in Math Nation. So pre-image, that's this one, and the post-image, that's this one here. I don't know if you can even see my mouse. So this is the let's see, the pre-image, and then the post image there and there. So that hopefully that helps. All right, so and this is named D or H D K N, and then H prime D prime K prime N prime. All right, so that's how that one works. So it's asking us what is the algebraic description that describes this transformation. So it's all it's asking is if I have any point on this polygon, and I know the x value and I know the y value, well, how can I describe in terms of x and in terms of y um, how this polygon moved? Right. So if I pick any point on this polygon, how much did the x and the y move? Okay, well, so the way I do this is I can just pick any point. We're going to start with D, right? I have D here, and I'm going to go D. I'm going to count how much D moved, right? And I'm going to have this new pen. I'm going to give it a go and see how well it works, right? So let's see. I got D here, and it moves. Let's see, 1, 2, 3, 4, 5 over an X. That's -5. And then 1, 2, 3 down. So the change in X, it's a really bad delta. Yeah, go back. That's my back button. There we go. My change in X. Select that again. So my change in X, change in X. It's a bad X. I'm using this new pen that I have. It's not working too good. Is -3. Oh, correction. All right. Is -5. My change in Y. This is tough. Change in Y is -5. -3. Sorry about that. -5. So change in X is -5, and a change in Y is -3. Let me go back to that good old regular mouse, see if it's any better. All right, so now let's look at how much K moved. All right, so K moved, let's see, -5 this way and -3 this way. So my change in X for K is -5, and my change in Y for K was -3. And you can kind of see the pattern here. If I look at my H, right, I'm going to go this way so it doesn't get as cluttered. It's -3 downward, and then -5. Change to y is -3. -3. Am I changing y? Or sorry, x equals -5. And then again, change in n is -3 again, and then -5 for x. -5 for x. And change in y equals -3, right? So they're all the same. That means at any point in this polygon, we'll say it's, well, I already used that one too. Say that like this one, right? Any point that we would choose, if it's inside this polygon or part of this polygon, during this translation or after this translation, it moved 5 to the left and 3 down. So that means that my algebraic description would be x comma y, right? It would mean it would be x minus 5, comma, then y minus 3. All right, so given any x, y coordinate, if I subtract 5 from the original x and then subtract 3 from the original y, that would be my original point on the polygon. So that is how you show the algebraic description for a translation. Remember, this is one of those rigid, or also known as isometric transformations. Isometric or rigid transformations. So hopefully this helped you out. There's another one in this section about rotations, and we'll get to that one directly. I hope this one was useful. Where is the quit button? Well, there's the quit button there, and I will stop with that.